ಒಂದು ಪ್ರಾಬ್ಲಮ್ನ ನೀವು ಟ್ರೈ ಮಾಡಿ ಅಂತ ಬಿಟ್ಟಿದ್ದೆ. ಸೊ ಅದನ್ನು ನಿಮಗೆ ಮಾಡಿ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಎ ಕಂಡಕ್ಟರ್ ಹ್ಯಾಸ್ 14.4 10⁻⁻19 ಕೂಲಮ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಸೊ ಕಂಡಕ್ಟರ್ನ ಮೇಲೆ ಇರೋ ಚಾರ್ಜ್ನ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ದ ಕಂಡಕ್ಟರ್ ಹ್ಯಾಸ್, ಕಂಡಕ್ಟರ್ ಹಾಗಿದ್ರೆ ಕಂಡಕ್ಟರ್ ಏನಾಗಿದೆ ಅಂತ ಕೇಳ್ತಾರೆ. ಆಪ್ಷನ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. 9 electrons in excess, 20 electrons in short, 20 electrons in excess and electrons in short. ಅಂದರೆ what we have to find is we have to find out the number of electron. ಸೊ ನಮ್ಗೆ ಡೆಫಿನೆಟ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂದ ತಕ್ಷಣ ನಾನು ಮೊನ್ನೆ ಪಾಠ ಮಾಡ್ತಾ ನಿಮ್ಗೆ ತಿಳಿಸಿದ್ದೀನಿ. ಎಲೆಕ್ಟ್ರಾನ್ನ ಡಿಫಿಷಿಯನ್ಸ್, ಎಲೆಕ್ಟ್ರಾನ್ ಶಾರ್ಟ್ ಆದರೆ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಹಾಗಿದ್ರೆ ಆಪ್ಷನ್ ಬಿ ಮತ್ತು ಡಿಯಲ್ಲಿ ಒಂದು ಆಪ್ಷನ್ ಇರಲೇಬೇಕು. ಬಟ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು? ಸೊ ಇದಕ್ಕೆ ನಮ್ಮ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ Q is equal to Ne. So N should be equal to Q by E. So what is the Q given? Q is 14.4 10 raised to minus 19. The charge of electron is 1.6 10 to the power of minus 19. So you can see 10 powers get cancelled. So we are left with 14.4 divided by 1.6. Let us shift the decimal, that is 144 divided by 16, which will be 9. So 9 electrons is in short. ಹಾಗಿದ್ರೆ ನಮ್ಮ ಆಪ್ಷನ್ ಏನಾಗುತ್ತೆ? ಆಪ್ಷನ್ ಡಿ ಆಗುತ್ತೆ ಇದಕ್ಕೆ. ಈಗ ಮುಂದಿನ ಕಾನ್ಸೆಪ್ಟ್ಸಿಗೆ ಹೋಗೋಣ. ಸೊ ಮುಂದಿನ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಯಾವುದು? ಕೂಲಾಂಬ್ಸ್ ಲಾ. ಸೊ ಕೂಲಾಂಬ್ಸ್ ಲಾನ ಥಿಯರಿಲಿ ಕಲ್ತಿದ್ದೀವಿ. ಕೂಲಾಂಬ್ಸ್ ಲಾನ ಸ್ಟೇಟ್ಮೆಂಟು that is electrostatic force between 2 point charges is directly proportional to product of magnitude of the charges and inversely proportional to square of the distance between 2 point charges ಅಂತೇಳಿ ನಾವು ಕಲ್ತಿದ್ದೀವಿ. ಸಿಂಪಲ್ ಆಗಿ ಲಾನ್ ನೋಡ್ತಾ ಇದ್ದೀವಿ. This is the law we have learnt. So when you combine all those equation, we end up with the formula F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So this equation shows that charges are in free space, which is air. If you keep same two charges in any medium separated by same distance whose dielectric constant is K, then we write the formula for force as force in a medium Fm will be 1 by 4 pi epsilon naught K Q1 Q2 divided by R square. This is the formula for two charges separated by distance r in a medium where K is electric constant. So this is Coulomb's law. ಸಿಂಪಲ್ ಆಗಿ ಕೂಲಾಂಬ್ಸ್ನ ರಿಕಾಲ್ ಮಾಡ್ಕೊಂಡ್ವಿ ನಾವು ಇಲ್ಲಿ. ಹಾಗೆ ನಾನಿವತ್ತು ಈ ಕೂಲಾಂಬ್ಸ್ ಲಾನ ಜೊತೆಗೆ ಒಂದು ಫಸ್ಟ್ PUC ಒಂದು ಈಕ್ವೇಷನ್ಸ ನಾನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ದಟ್ ಈಸ್ forces between two masses. So forces between two masses is very famously called as gravitational force, right? So that is given by the equation F is equal to G m1 m2 divided by R square, where R is again distance between two masses. ಈ ಫಾರ್ಮುಲಾ ಇವತ್ತು ನಾನು ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಐ ರೈಟ್ ಇಟ್ ಆಸ್ FG, ದಟ್ ಈಸ್ ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್ ಅಂತ ನಾನು ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. Okay, then let us go back to again second PUC concept where we study force on a single charge due to multiple charges. That is superposition principle we have studied. So if I have a single charge here, let us say this charge is Q and this charge is separated by another charge. Let us say this charge is Q2, this charge is Q1 at a distance say R1. This charge experiences force due to Q2. If it is like, it repel, and let us call this force as F1. We can write the formula for F1 using Coulomb's law. I have one more charge. Let us call this charge as Q3 and this distance is R2. Again Q3 would either attract or repel the first charge with a force, let us say F2. If I have another charge, let us say this charge is Q4, this charge will again either attract or repel this first charge Q1 with a force F3. When we have multiple charges, say Q2, Q3, Q4 surrounding the charge Q1, then Q1 will experience force by each charge. Now this resultant force can be found using vector addition. That is, vector F will be equal to vector F1 plus vector F2 plus so on, right? Here we have to use one more equation that we studied in our first PUC. That is, resultant of any two vectors is given by the equation R is equal to root of P square Q square plus 2pq cos theta, where p is one vector which is making an angle theta with another vector, say, which is vector q. Then you can find the resultant between these two vectors using the equation that is mentioned here, and that I'm highlighting in reading now. You can see this. So you can find the resultant of two vectors using this equation. So I'm using this equation today, and let us solve problem on the second concept, that is Coulomb's law. Even I will be using another first PUC equation, which is force is given by the equation F is equal to ma, which is Newton's famous second law, right? I will be using this equation as well today. Okay, problem here. 2 point charges A and B having charges plus q and minus q respectively are placed at a certain distance apart. So ಎರಡು ಚಾರ್ಜ್ಗಳನ್ನ certain distance ಅಲ್ಲಿ ದೂರ ಇಟ್ಟಿದ್ದಾರೆ, and force acting between them is F. So they are experiencing a force F. So let us write this in our diagram. That is, there's a charge kept at A, point charge, another charge kept at point B. Both of them are having same magnitude Q, but the sign is opposite. So this is two charges separated by certain distance. They have not given the distance. Let us take this distance as, say, R. Then from Coulomb's law, we can write the formula F is equal to 1 by 4 pi epsilon naught. This is q square divided by r square. Since it is q1 and q2, q1 is q, q2 is also q, therefore it is q square, right? This is the force between two charges. Now, what is the problem here? 25% of charge A is transferred to charge B. So from charge A, 25% of charge A is transferred to charge B. That means we are getting a new value of charge now, right? Question, then force between the charges becomes, that is, there is no change in distance, just the 25% of charge has been given from A to B. Let us find out this case now. See, 25%, you can write this as 25 divided by 100, which is 0.25. And when you are solving competitive exams and problems, you have to take them in ratios, like 0.25 is 1 by 4. That is, 1/4 of the charge of A is transferred to B. This is what is given in the problem. Okay, now let us see the charge values now. See, this Q has lost 1/4 of its initial charge. That means 25%. Okay, then the negative charge minus Q is gaining 1/4 of the plus Q charge. As I repeat this, charge Q is losing 1/4 of its charge, and this charge has been transferred to minus Q. That is, minus Q is gaining, therefore I have written plus 4, plus here plus 1 by 4. So this is gaining 1/4 of the plus Q charge. Then what are the new charges now? Now the charge at A will be 3 by 4Q, right? And the charge here is also, this is minus 3 by 4Q, because this is negative charge and this is plus 1 by 4. So very simple, minus 1 plus 1 by 4, you think like this. So this will be equal to minus 3 by 4, right? So similarly, the initial one, this part, at this part, this is 1 minus 1 by 4, which is equal to plus 3 by 4. This is what I have written now. So the new charge is plus 3Q by 4, and here is minus 3Q by 4. Now what is the force between them? Again, F is equal to 1 by 4 pi epsilon naught. This is 3 by 4Q into 3 by 4Q again divided by R square. That is, F is 1 by 4 pi epsilon naught. This is Q into Q, which is again Q square divided by R square. But in numerator, it is 3 by 4 into 3 by 4. So this will give you 9 by 16, the initial value. Initial value is F. So it is again F and F. Don't get confused. Let us call this as F dash. So the new force will be 9 by 16F. So that is our answer, option C. Right, next problem. Two particles, each of mass m, carrying charges q. So in this problem we can see there's another data given, that is mass. That's why I mentioned earlier I will be using gravitational force today. Okay, they're separated by some distance, ಸ್ವಲ್ಪ ದೂರದಲ್ಲಿ ಚಾರ್ಜಸ್ ಗಳನ್ನ ಇಟ್ಟಿದ್ದಾರೆ. If they are in equilibrium under mutual gravitation electrostatic force. So these two charges are experiencing two forces, one is gravity, other one is electrostatic force. Despite experiencing two forces, ಎರಡು ಫೋರ್ಸ್ಗಳಿದ್ರೂ ಸಹ ಆ ಒಂದು ಚಾರ್ಜಸ್ಗಳು ಈಕ್ವಲಿಬ್ರಿಯಮ್ ಅಲ್ಲಿ ಇದೆ. That means two forces are acting on the bodies are cancelling each other. How they can cancel each other? Only when they are equal and opposite. That is Newton's third law. Now, how do I represent this? ಹೇಗೆ represent ಮಾಡ್ತೀನಿ? If I write this charge q here and another charge q here, they will be experiencing electrostatic force. But to be in equilibrium, gravity is also required. So if I take charges horizontally, then say gravity will be acting downward. This gravitational force can never cancel electrostatic force if forces are perpendicular. This is electrostatic force, this is gravitational force. They cannot cancel each other. When do they can cancel each other? When they are acting along the same line. That means ಎರಡು ಫೋರ್ಸ್ಗಳು ಒಂದೇ ಲೈನ್ ಕಡೆಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರಬೇಕು. ಹಾಗಾಗಿ ಡಯಾಗ್ರಾಮ್ನ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಸೊ ದ ಚಾರ್ಜ್ q here, another charge q here. Now this charge will definitely fall because of gravitational force. But this another charge here, because they are like charges, this charge will tend to repel this charge. So when this first charge, that is the charge here, if it is repelled by the second charge, then electrostatic force will be acting upward. Now there is a possibility that Fe can cancel Fg. There is a possibility, right? This is how we have write the diagram. Okay, now these two forces are equal and they are opposite. That means I write this equation for Fe and Fg separately. But what is the condition for equilibrium? Fe should be equal to Fg. So what is the formula for Fe? Fe is, since I am solving the problem where I will be getting the answer in numerics. Okay, so ಒಂದು ಫೈನಲ್ ಆಗಿ ನನಗೆ ನಂಬರ್ ಬರ್ತಾ ಇದೆ, ಅದರಿಂದ ಐ ರೈಟ್ ದಿಸ್ ಆಸ್ 1 by 4 pi epsilon naught as 9 into 10 to the power of 9. Then charges are q into q, which is q square. There is no mention about the distance. Let us call it as r square is equal to addition force formula. This is G m1 m2. Since masses are same, you can write it as now m square divided by distance between them again is r square. Now we can see r square get cancelled. Okay, then what we are left with, 9 into 10 to the power of 9 q square is equal to, what is G value? G is 6.67 10 to the power of minus 11, then again m square. Now since question is all about finding the order, that is 10 power, let us see q square by m square. I have taken this m square to denominator, which will be equal to 6.6, that is enough, 10 to the power of minus 11 divided by 9 into 10 to the power of 9. Okay, so when I divide this, so 6.6, if I divide it by 9, this is almost, not exactly, approximately this is 1. So 6.6 here, 6.6 is very close to 9. So this is approximately, we can say it as 1 into 10 to the power of minus 20. So the order for this is 10 to the power of minus 20. But one second, there is q square by m square. So this is q square by m square. So we have to find q by m. That is square root of 10 power minus 20, which is 10 power minus 10. So therefore the answer is not this one, answer is this one. Okay, next question. Under the action of given Coulombic force, acceleration of an electron is 2.5 10 power 22 meter per second square. So that is the acceleration produced on electron. Let us mention this acceleration of electron. What is given is 2.5 10 to the power of 22. Then magnitude of acceleration of a proton. So we have to find out acceleration of proton under the action of same force. So whatever force is given to electron, the same force is also given to proton. Electron ಗೆ force ಕೊಟ್ಟಿದೆ, proton ಗೆ ಅಷ್ಟೇ force ಕೊಟ್ರೆ what is the acceleration ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಇಲ್ಲೊಂದು ಪಾಯಿಂಟ್ ಅರ್ಥ ಆಗಬೇಕಾಗಿರೋದು, ಎಲೆಕ್ಟ್ರಾನ್ ಅಂಡ್ ಪ್ರೋಟಾನ್ ದೇ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ ಮಾಸಸ್. ಓಕೆ, ಅಂಡ್ ಮಾಸ್ ಆಫ್ ಪ್ರೋಟಾನ್ is approximately 2000 times the mass of electron. To be precise, this is 1896 times the mass of electron. So proton in a mass, electron a mass compare ಮಾಡಿದಾಗ ಇಷ್ಟು ಟೈಮ್ಸ್ ಹೆವಿಯರ್ ಆಗಿ ಇರುತ್ತೆ. ನಾವು ಅದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ 2000 ಟೈಮ್ಸ್ ಅಂತ. ಸೊ ಫೈನಲ್ ಆನ್ಸರಲ್ಲಿ ಈ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ನಿಮಗೆ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ವಾಟ್ ಈಸ್ ಮೆನ್ಷನ್ಡ್ ಹಿಯರ್? Under the action of same force, that is proton and electron are experiencing same force. That means force on proton is exactly equal to force on electron. So what is the formula for force on proton? Mass into acceleration. Let us write the proton as subscript and mass acceleration of electron. Now acceleration of proton is what we have to find. So AP will be equal to the ME divided by MP into AE, right? So AP will be equal to, AP will be equal to, so what is this ME and MP relation? So ME, let us write as it is, but MP has approximately 2000 times the value of ME into AE. AE value is already given to us. We know the value of AE here. Therefore, let us substitute the value of AE, which is 2.5 10 to the power of 22. Now acceleration of proton will be equal to 2.5 10 power 22 divided by 2 into 10 to the power of 3. Right? This is 10 power 3. Then we have got the answer. When you divide 2.5 by 2, it should be approximately 1.25 into 10 to the power of 19. Now if I check the answer, I have 10 power 19 here, so this should be our answer. But there is a there is a doubt here, that is how do I get 1.5 and the answer is 1.25 and answer is 1.5. As I told you, the approximate value, but exact value is 1896 or 97 times the mass of electron. So it is slightly less than 2000. So when the denominator value is less, numerator value will be more. So the exact answer for this question will be answer C, 1.5 10 to the power of 19 meter per second square.